Hello everyone, this is Wong from San Jose State University in California. I'm working with Mohammed Badawi. Together we are doing this education training material. Just a quick introduction to San Jose State University. We are in the Silicon Valley, and we envisage that more and more engineers will work in the power industry. And that's why we created this course or this training material to train the students to work in the power industry. The title of our project is Development of Low-Cost Graduate Course with Virtual Fab and Hands-on Circuit Lab Experience to prepare students to work in the silicon carbide industry in Silicon Valley. So we pay attention to the silicon carbide, and this one we try to develop 5 low-cost and low-risk course modules which you can combine together or put into your course, and that they will learn from silicon carbide fabrication to test bench measurement and to power converter, schematic design, PCB layout, and prototyping. And this will help them to be ready to work in the WBG industry. And we think that this will not just benefit the student, but also can transform the traditional silicon engineer to work in the WBG industry. So as mentioned, we will create 5 course modules in this project, including virtual silicon carbide fab, virtual silicon carbide test bench, circuit level simulation, board level circuit design, and PCB prototyping. For the first 4, they are all simulation, and the student can do and make any mistake they want and learn from the mistake. And in the last one, it will be a prototyping that we are going to use the TI evaluation board with full-speed silicon carbide MOSFET. For the virtual fab and test bench, we use TCAD. TCAD is technology CAD, which it can be used to solve partial differential equations of the physics in silicon carbide. So they will appreciate the difference between the silicon carbide and silicon industry. And for the circuit level simulation, they are going to use OrCAD Designer and also Tina Simulator from TI to perform the circuit simulation. And then they will transform the circuit to PCB layout. So besides these examples, we are going to create teaching slides or videos to cover so that the students or the instructor can use as a reference. And we are going to evaluate this material in our classes in San Jose State University, EE222, which is Semiconductor Devices 2, in which we cover the WBG materials and WBG devices. And another class is the selected topics on electrical vehicle and renewable energy system in EE239. So far, this is our accomplishment. The first thing is we created a rapid 3D process emulation flow by using Synopsys SPX or Process Explorer. All the student need to do is to import the GDS of this power MOSFET, and then there will be a flow provided to them. This is a typical flow, and they can change by themselves if they want by adding different steps. And here you can see that we have a very huge simulation domain from the TCAD perspective, right? It is almost in the millimeter order. And you can see that it can generate all different step snapshots within minutes, if not seconds. And the student can cut at any places in the device or the structure to see how the device layout. For example, here shows the finger. The red one is the poly, right, of the transistor fingers. And with this, they will be able to appreciate the overall topology of the silicon carbide device. We also have done 2D process simulation. The one I showed you earlier is emulation. It does not contain all the physics. Here, it has the real physics. Now, the students can compare this against silicon. For example, here that they can change the implantation energy, annealing temperature, oxidation type. For example, from here, they will appreciate that for the activation, right? For silicon carbide, we need 1600 degrees C, while for silicon, we only need 900 degrees C in order to get a similar junction depth. And also they will find that if we use the same thermal budget for the oxidation in silicon carbide on silicon, you have to get something ridiculously thick oxide. So this is particularly useful to transform the silicon industry engineer to silicon carbide. We also make the virtual test bench in which you will, the student will be able to simulate all types of the importance measurement, IDVD, IDVG, CV, BV, gate charge, short circuit, UIS, and switching losses, right? And student will learn the importance of incomplete ionization, interfacial traps, and also high temperature leakage in silicon carbide compared to silicon, right? For example, here we show that while we have this very high nitrogen concentration doping, but those that really ionize is not as much as we expect. And here shows two curves, the breakdown voltage of silicon, and the red one is silicon carbide and the blue one is silicon. And they can appreciate that the silicon first start with a higher leakage current, and then it also breaks down at lower voltage. And we have also finished the schematic design training material. Here shows the schematic that was created in Cadence ORCAD. And actually we have simulated this in TITNet. So with this, the students will be able to use circuit simulation. We have also finished the PCB design training material. Here shows the PCB layout, and by using the Cadence algorithm. In particular, we try not to create individual trace, right? Our students try to use. After the layouts, then we will do PCB verification training material. This is almost 75% done. What we do is we use ANSYS to do the testing. Here shows the ANSYS SI wave, and here is the ANSYS IC pad result. Right? We simulate the signal integrity, power integrity, EMI, etc. Right? Currently, we are doing the power integrity and simulating with a PDN network. So in the next step, we are going to simulate the signal integrity for PWM signal and also the thermal parameter of the MOSFET. So we are almost done with the project, except that the last one, which is the hands-on prototyping and experimental verification, it was halted because of COVID-19 and our school's lab has been shut down since March. But we are reopening gradually, so we should be able to complete it in the coming few months. And we keep improving the teaching material, and we will evaluate the training material in our graduate class in the coming year.